Thanks, Michael. So my research is really at the intersection of security and networking. And some of the research we've been doing recently is really about how do you sort of rethink the way network security is done today and sort of accelerating the rate of innovation in deploying novel security features and helping us deal with new and emerging network security threats. And sort of that's really where the research we're doing comes from. So to give you some context about kind of what a Middlebox is and why this is the Middlebox Manifesto, sort of let's take a step back and look at what we teach in Networking 101 to our students, right? So Networking 101, the traditional view of a network is a dumb network. It's just sort of pushing bits from point A to point B. You have these dumb switches and routers that just do basic forwarding. But the reality, so the reality, and you guys would know from sort of operational practices, is the reality is actually there's a lot of sophisticated in-network processing going on. And a lot of these are really for network security purposes. And these are called network appliances in the industry, or in the research world, we call them middle boxes. So it's anything that's not a switch or a router that's being put in the network to serve a particular purpose. So these are things like firewalls, intrusion detection systems, intrusion prevention systems, packet scrubbers, proxies, application gateways, VPN gateways, IPsec boxes, and the whole gamut of possible boxes you need to meet your network requirements. It turns out actually that these actually are a very critical piece of the network security infrastructure today. And we did surveys of some very large enterprise networks and also a broader survey across several network operators spanning different network segments. And what we found across the board, so on the table on the left-hand side, as well as on the box and whiskers plot on the right-hand side, is that across different market segments, we actually see that these kinds of middle boxes play a very, very critical role in the network infrastructure today. So in fact, the number of these middle boxes, if you look at the table, is almost on par with the traditional networking infrastructure. So when you think of a network, you think of switches and routers, but it turns out these additional boxes like firewalls, gateways, NIDs, and so on, are actually it's almost paralleling the traditional network infrastructure. And this is true across different market segments. Small networks, medium networks, enterprise networks, data center networks, everything has a lot of these middle boxes. And there is in fact a huge market for middle boxes. So the market for network security appliances alone is in the order of like tens of billions of dollars. And there's many more sort of people are using them for like performance and other kinds of policy compliance capabilities as well. Now, clearly, people sort of the operational community perceives a lot of value from these middle boxes, and the reason they deploy them is because they provide these kinds of capabilities that they cannot achieve with their Cisco and Juniper routers and switches. So there's a lot of value in these boxes because they serve a key role in the infrastructure. But at the same time, sort of our talks and our discussions with network operators suggest that there's a lot of like pain points in them sort of working with these middle box devices today. The first pain point that operators have told us, and we've had a long discussion with many of these network operators, is that these boxes are simply too expensive, right? So they have to buy a firewall, and it costs like in sort of north of like hundreds of thousands of dollars. And it also adds to the clutter in the network. So every time they need a new functionality, they have to go buy a box and plug it and patch it into the network. So it kind of creates a lot of network clutter. A second problem with these kinds of specialized network appliances is that it actually increases the management complexity of a network. In fact, the large enterprise network from which the table comes from, they actually have like separate teams for managing and tuning and configuring each class of network appliance. So they have a firewall team, they have a WAN optimization team, they have a load balancing team, they have an IDS team, they have a VPN team, and so on. Because sort of each kind of these kind of functionality comes with its own crazy configuration protocols and so on. So they need to really understand the low-level details of each of these boxes, and that requires separate management teams for each of these functions. And the third, and perhaps sort of a more significant challenge for them, is that once they buy this fixed hardware and they plug it into the network, it's kind of this, they're sort of committed to this, and it creates this inflexibility in the network. So for example, many enterprises are moving towards this sort of bring your own device attitude, like where you want to let your employees bring their own laptops, bring their own tablets and phones and so on. So naturally, you need like some kind of security infrastructure to make sure these sort of employee-owned devices come inside the network. Now, the only way for a network operator to sort of react to this trend is actually to go and buy new boxes, like you buy an iPhone gateway, you buy an Android gateway, and so on. And the reason is that sort of the existing infrastructure cannot be easily extended to add new functionalities as your application landscape changes. And there's also an even bigger problem is actually that these are actually difficult to upgrade. So there's a little bit of irony here. So when Heartbleed came out, one of the problems people perceived is that actually they have a network security infrastructure like firewalls and proxies and so on that were actually running vulnerable versions of OpenSSL. And those were actually much more difficult to upgrade than your traditional servers, because this is like, it's almost like doing like a firmware upgrade, and it requires the vendor to come and support and patch this. And this could take months. Whereas if you have a commodity server, you just run the software update and you're done. So it's almost like ironic that your network security infrastructure becomes your vulnerability when you have vulnerabilities in the software stack of these things. So sort of the status quo today is that these are a critical piece of the network security infrastructure, but they kind of have this high cost, high complexity, and they're difficult to extend to add new features. So both in terms of upgrading them to react to vulnerabilities, as well as sort of adding new functionality to react to changing applications and changing threats. Sort of the overall vision of our group is sort of thinking about like, how do we address all of these pain points? And that's where sort of the unleashing innovation aspect of what we are working on comes in, right? And the overall vision for us is to sort of enable innovation in different aspects of this space. So for example, we're looking at how do we build a common open platform for developing new in-network functions. So if you want to develop a new firewall, rather than have to rewrite a firewall software from scratch, can we provide an extensible platform for building firewalls or new IDS capabilities? And once you have this kind of platform, you can almost think about some kind of a logical app store, right? Rather than have to go to Cisco each time, imagine you had like an Apple app store for buying a new network security function, and that could be plugged in onto this on-demand platform. Correspondingly, we actually need the kinds of control and orchestration capabilities to manage these in-network functions. So you have this infrastructure, how do we actually make sure that your network's policy, your security policy is implemented correctly, and you're building the right kinds of like orchestration capabilities. And on top of these, we're actually looking at what kinds of new and novel security features and robust security features can we build. And finally, so one of the ways to sort of deal with the complexity of the existing infrastructure is that it's actually very difficult for a network administrator to reason about what's happening inside the network. So we're also building new kinds of testing and verification capabilities that let administrators sort of systematically ensure that the network is actually meeting their security properties. So this is really the overall sort of overarching vision of where we are going in terms of improving the status quo of network security. And what I'll do in the rest of this talk is give you a brief flavor of some of the early work that we have done in this space. In terms of like three topic areas. So as I said, the three main challenges are high cost, inflexibility, and high management complexity. And some of the work we've done to address these problems, for example, we proposed a new architecture for building these kinds of network security appliances that can address all of these challenges. We've also done some initial work in leveraging cloud-based outsourcing or offloading of these network functions to address some of the management and inflexibility challenges. And finally, looking at sort of connections to this emerging theme of software-defined networking. I'm guessing many of you have heard of software-defined networking. So we're looking at how can software-defined networking or SDN help us in the space of Middlebox management. So I'm just going to give you like a broad overview of the kind of problems and solutions that we've come up with. I'm happy to chat more offline if you want like more details or pointers to any of the individual research that we've done. So the first piece of work I'm going to talk about is actually what I call a consolidated architecture that's attempting to solve all of these problems in one go. So it's sort of this sort of radical clean slate design of rethinking how these network security appliances are built that can address all of these challenges. And the vision here is that today, each kind of network security feature, like a proxy, a firewall, an IDS, or a application level firewall, and so on, is built as a standalone and specialized appliance. So you kind of go buy a firewall from Checkpoint, you go buy an IDS from SourceFire, and so on. So it's built as standalone and specialized hardware. And that's really causing the high cost and this sort of the network clutter and so on. So our vision is actually to say, well, can we bring some of these ideas that virtualization has brought us to improve the status quo here? And the idea here is to sort of say, why not decouple the underlying software and hardware of these network appliances? And instead of running sort of standalone specialized hardware, why not run these as software modules on commodity hardware? And here we can leverage a lot of recent advances in the networking space that show that it is in fact to build these type of high performance network appliances on commodity hardware. And that's actually an encouraging trend for us to build these new security capabilities. Now, in fact, once you do this sort of decoupling of the hardware and software, it actually enables new opportunities. In particular, you can now think about refactoring the way you write the software for these network appliances. So rather than each vendor, like say a firewall vendor or an IDS vendor, inventing the whole software stack, so doing packet processing, connection reassembly, application level parsing, and so on, you can now imagine that if you have a consolidated architecture, you can actually reuse a lot of the processing and the code across these different functions. So for example, you can say, oh, I can share the protocol parsing logic or the results of the protocol parsing across the IDS and the firewall. And that actually can significantly improve the performance and scalability of the system. And looking forward, sort of, this is really looking at consolidation at a single appliance level. And we can actually take these ideas and extend it to sort of a more system-wide level as well. And we've shown that we can in fact consolidate the management of these appliances across the whole network. So rather than think of a device-centric view of managing each and every appliance, you can think about these are just resources that need to be managed in a concerted manner across the whole network. And we've shown that this actually gives you a significant benefit in terms of performance and scalability and being able to handle unpredictable traffic surges relative to sort of the status quo. So that's one thread of work, which is really sort of this more radical clean slate design of how we design and manage network appliances. The other two threads are a little bit more incrementally deployable. And in particular, one of the things we're looking at is looking at cloud-based outsourcing of network functions or these network security functions to improve the scalability and improve the flexibility. So what's the vision here? The vision here is that the traditional way people think of sort of cloud security is that the cloud is kind of the enemy, right? Sort of the cloud creates security problems. But in fact, we actually think that in the context of these kind of network security functions, the cloud can actually be a partner. And the reason is that you can now dynamically scale your network security deployment or dynamically invoke new security features like packet scrubbing or an application level firewall that you don't have, but a cloud provider can offer this as a dynamic service to enterprise networks. And we actually believe that this is actually better aligned with industry trends, right? So the cloud providers are not our enemies. They actually could be our friends in improving the status quo of network security. And more importantly, for sort of enterprise networks, getting new security features or testing new security features, this may actually offer a nice incrementally deployable path where you want to test a new firewall or a new IDS feature, you can use it as a cloud-based service rather than have to upgrade your local hardware infrastructure. And so one natural concern with offloading some of these network functions, which is on the critical path of user traffic, is performance and scalability and so on. But we've actually shown that we've had a pilot deployment of simulating an enterprise network and showed that it is in fact possible to realize a practical cloud-based outsourcing architecture. And we've shown that this cloud-based offloading brings the benefits of cloud computing, like economies of scale and per use, and also simplifies the network configuration inside the enterprise. So sort of the traditional enterprise, you actually had all of this clutter with these boxes inside the network. but we now move them as like services into the cloud in some sense. And this provides sort of a significant improvement in the configuration complexity of your enterprise networks. So that's about a more incremental deployable way of deploying new network security functions by leveraging the power of and the scale of cloud providers. A third theme of research that we've been looking at is how can SDN or software-defined networking help the status quo of network security. So I'm not sure, like most of you, if you're familiar with SDN, but let me just give you a quick, very, very high-level overview of what SDN is. So the problem SDN is trying to solve is really the traditional way people have been thinking about network configuration is this very device or router-centric view, right? So when a network operator wants to configure a network to do something, the tools are very low level. These are like Cisco iOS commands that the network operator has to go and tweak to get the network to behave in a particular way. So what SDN is trying to do is actually sort of give operators better toolkits rather than think about these low-level iOS commands and tools on each individual router. It actually tries to think about the network as a whole. And in particular, what it's doing is it's sort of consolidating the management to a logically centralized location. And it's providing open APIs to configure individual elements. So this way, the switches are much simpler. All they have to do is provide a simple interface of doing an action for a particular flow. So the action could be a drop or a forward or applying some ACL rule. And all of these actions are logically controlled from a centralized location. And the nice thing about this is that it simplifies network management. Now, in the previous view of the world, the operator has to reverse engineer in some sense what is the overall effect of changing each individual router configuration file. But now you can think about the operator as writing this control program to manage the whole network in one piece, as opposed to reverse engineering the effect of each of those Cisco iOS commands. Now this is all great. I mean, so SDN has been really good, and it's kind of helping revolutionize the networking industry. But one critical missing piece in SDN today, and that's the focus of our work, is what about these kinds of advanced network functions? I mean, routing and forwarding is great, but people actually perceive a lot more layer 4 and layer 7 application level services via these middle boxes. And that seems like a critical missing piece in SDN today. And many industry analysts actually confirm this. They actually feel that these kinds of application level processing is both a necessity and an opportunity for SDN to sort of demonstrate real value for real networks. So our work in this space of sort of SDN and Middlebox integration has really been on like how can we leverage SDN capabilities and extend SDN capabilities for systematic policy enforcement. So the idea is that if you have a high-level Middlebox policy of like chaining different services for different application classes, how can we leverage SDN capabilities to enforce that and make sure that those are working correctly? And we've provided mechanisms for systematic policy enforcement. We've actually developed orchestration mechanisms. And we've also developed new API for extending SDN to handle some of these corner cases of integrating middle boxes. So in some sense, we're also pushing the envelope of SDN to handle these kinds of middle box behaviors. So that's sort of in a nutshell, that's kind of what we're looking at is like how can these combination of these ideas like a consolidated architecture, cloud outsourcing, and software-defined networking help us address all of these pain points with existing infrastructure. Now that said, most of these are really kind of on the infrastructure pieces, right? These are really enablers that you're using, sort of building the orchestration capabilities to build something interesting on top of it. And I view these kinds of mechanisms as really enablers for developing new kinds of security capabilities. So for example, we've actually developed new mechanisms for systematically testing and verifying that the network is implementing your security policy correctly. So this was the poster that was there outside on the system called Buzz that is exploiting some of these ideas to systematically test networks. We've also been looking at new mechanisms for building better DDoS defense mechanisms for networks by leveraging some of these SDN principles or some of these principles of being able to program the networks better. And the other kinds of new applications we're looking at is what I call precise security implementation. And the idea here is that, so today, sort of the way that the tools that we give our network security admins is actually pretty coarse. They kind of have these really coarse hammers in which to restrict the actions of users, because they have to constantly fear user backlash and users fighting against restrictiveness. And also they suffer with this issue of like too many false positives. And the reason is that the lenses that they use to detect attacks inside the networks are really coarse. So you kind of have this one-size-fits-all policy. But with some of these orchestration mechanisms we're talking about, we believe that it's actually possible to rethink the way you implement your network security policies to finally customize your policy for individual devices. So for example, imagine that you have a medical scanner, or you have an MRI scanner, or a printer in your office that you really can really constrain what it has to do or what it can do by having a model of what that particular device or asset can or cannot do. And that you can actually implement as a more precise security policy using some of these capabilities that we are developing. And actually, this is just the beginning. I think what we're looking for from you folks is actually what kinds of new security features that you want. So if we had all of these capabilities for programming new network features, what kinds of security features would you like to see developed using these? And there's many more sort of open research questions here that we would love to hear your views on. In terms of the platform side, there's interesting questions on what is the right software architecture. There's interesting questions on sort of the hardware side. What's the right kind of network appliance hardware that you would need? There's interesting questions on the security applications, as I mentioned. What kind of new security apps would you like to see developed on top of this kind of infrastructure we are building? There's new kinds of test and verification mechanisms that we need to make sure that this sort of all this complexity is managed well. There's interesting questions on management interfaces. There's interesting questions on sort of operating systems abstractions for isolation inside these platforms. And there's also interesting questions about policies. Like, for example, what typical policies are being used in network security today, and understanding those policies and seeing how well we can implement or test those policies in the kinds of infrastructures we are building today. And we would like to sort of hear your thoughts on all of these and many more open research questions in this space. Okay, so let me sort of quickly conclude. So the work we're doing is really sort of addressing innovation inside these sort of critical piece of infrastructure called network middle boxes. And these are critical for security and policy compliance, but it turns out there's actually been very little research in how they are designed and how they are managed. So the consequence of that sort of ad hoc approach that people are using today is high capex, high opex, inflexibility, and kind of a little bit of brittleness in making sure that the policy is actually implemented correctly. And we're providing sort of this, the vision, the grand vision is sort of accelerating innovation in the space, both in terms of building better platforms for deploying these functions, new management capabilities for orchestrating these functions, and as well as new testing frameworks. And I believe these are kind of going to be enablers for the future of building novel security services. And that's where you guys can help us and inform the research in telling us what kind of security capabilities you would like to see deployed on top of these orchestration mechanisms. That's it. Any questions? Yep.
This working?
Yep.
So one of the things I noticed is that security, while I heard about extendable services and things like that, one of the things that we utilize network versus the security team for most corporations is oversight. And I noticed that when you put everything in one box and it's that person that's doing everything down the line, it's called a segregation of duties problem. And so I would say that from viewing this, you're going to have a pretty decent problem with audit straight out. Normally, security would review network as an operational team and provide that second layer, right? But with this, we would definitely have an issue there. So how do you address segregation of duties? Not only that, but offshore personnel having, oversight over your core switch. How do you make that transparent in an area where application is having a hard time with transparency when you put it out in the cloud and you get into partnerships?
So I think that's a great question. I think the cloud outsourcing part, I think that's a definite concern. But you can think about the same kinds of capabilities we are doing can be in-house clouds. They don't necessarily have to be like public cloud providers. They could be in-house clouds, like say people the banks actually want to do in-house clouds and or private clouds as well. So this could be a private cloud service that you trust. So it's certainly possible. And in fact, going back to your question about like audit and visibility and so on, in fact, these kinds of system-wide orchestration mechanisms you're building actually give you better audit capabilities. In fact, you actually have a global view of what's happening inside a network, and you can systematically test each of these policies. And that's a capability you wouldn't have had before. I mean, if your policy was kind of distributed across the network, and your monitoring was distributed across the network, which is the way it's done today, you wouldn't have this global visibility. But we actually can give you global visibility now with kind of SDN features or the ability to program new audit trail capabilities. So the audit part, I'm not sure it's completely contradictory. In fact, I think this is an enabler for new kinds of audit trail features. And looking at packet provenance and so on, you could do with this some of the capabilities we're developing. That said, I'll have to think a little bit more about the segregation of features between sort of security team and networking teams. In my mind, I don't see them as different. I mean, I would like to see them as like an integrated team, as opposed to sort of two separate teams. Because I mean, I don't think you can really separate out security from networking, right? I mean, I don't think it's possible to do that. It seems hard for me to conceptually think about how do you take network security out of the security picture and then think about how secure something is. So I think they have to talk somehow, right? I would like to know how the people do it today. I mean, to me, I have a hard time believing that you can actually separate out those two functions. Yeah.
Any other questions for Vyas?
Thanks.